All this yellow on the railway line from Hamburg to Cuxhaven is a rare sight. In spring 2016, sections of the line near Stade are being renovated. Cleaning of the ballast bed, replacing rails and sleepers, and thorough maintenance of the track are among the tasks carried out in several phases of construction in a 3-week window. A full closure of the line can be avoided thanks to powerful, highly specialist but flexible track construction machines. And of course, everything is completed on time. Once the work is completed, both tracks will be reopened for traffic as planned. The Niederelbe from the Hamburg area to Cuxhaven, which is exactly 135 years old at the time the renovation work starts, is the northern end of the line from Lehrte to Cuxhaven with line number 1720. Since April 1, 1881, the line has been running from Hamburg-Harburg in northwest direction to the estuary of the river Elbe. Cuxhaven station is not accessed by intercity rail services. Therefore, the hourly connections of the so-called Metronome regional express train are well frequented. During the construction work over several weeks, a Metronome is not in operation. The suburban railway is bridging the gap between Buxtehude and Stade with longer intervals. Freight traffic is running as normal during the construction work. Cuxhaven is a departure and destination point for automotive logistics. To fully close the line was therefore not an option. Lot 20 of the construction project, which is carried out around Easter 2016, concerns the line section north of Horneburg as far as Agathenburg station, about 7 kilometers away. The section of track towards Cuxhaven needs to be renovated. The work is scheduled to take 27 days. In the early hours of the evening, the PM1000 URM by Plasser Theurer is prepared for its first deployment. The excavation chains are brought into position. Excavating the material, they are at the heart of the 52-axle row of wagons. Work can now begin. The entire worksite logistics takes place on the track under possession. The superstructure material is brought in by rail, so it's possible to keep the disruption to rail traffic and passengers to a minimum. The PM1000 is coupled with 2 additional construction trains, so that the delivery and removal of material does not grind to a halt. The construction train running behind the machine consists of transport wagons with containers which are to be loaded with new material for the interim shift. To facilitate this, a temporary storage area is set up on a road next to a level crossing. This makes distances shorter and saves time. While diggers and wheel loaders start loading the material, 2 gantry systems running at the top of the transport wagons are taking over the transport of the containers. The rear gantry unit is moving 2 containers at a time. The gantry unit nearer to the machine tips the contents of the container into the bunker of the PM1000. This is either the material for the formation protective layer or the ballast bed, depending on requirements. This relay system with container handover shortens the travelling distances of the 2 gantry units and thus considerably accelerates the processes. The PM1000 URM is able to deploy 3 excavation chains simultaneously and is as fast as it is thorough in excavating the existing material in any required width and depth. To save on the use of new ballast, its transport and the associated considerable cost, the existing ballast is first cleaned and treated. The recyclable components are reused. The unusable spoil is transported on conveyors to the second construction train at the front. The coupled MFS units there then move the spoil, separate from the PM1000, to disposal sites set up away from the track. Ballast cleaning and recycling, as well as applying a formation protective layer, are the strong points of the PM1000 URM. Depending on the quality of the existing track bed, it allows up to 100% reuse of the ballast bed material. It is mostly not necessary to fit geotextiles, since a 30 cm strong formation protective layer after compaction already provides the required load capacity values despite the nearby marshland. It becomes obvious that 135 years ago, people knew very well where to lay the track. Once the formation protective layer and ballast have been reinstalled, a tamping satellite with lifting and lining unit, which is integrated into the machine, concludes Phase 1 track tamping, with the old track still in place. Construction trains can travel on the track straight away at a remarkable speed of 70 km an hour. It is important that the machinery is able to work past passenger stations and other narrow places on the track without stopping, and without limitations to the work results. The PM1000 URM and the RU800S are able to work past narrow places such as bridges, railings and level crossings by adjusting the working width of excavating chains and plate compactors. Regardless of their design and height, platform edges are no obstacle for the RU800S, which is specially equipped to deal with them. An impressive example of this was demonstrated at Dollond platform, which is 76 centimeters high and in a curve. The RU800S by Plasser Theurer is the second machine used at this worksite. It cleans the ballast in those places where the PM1000 has not been working. Its core purpose, however, is the continuous rail replacement. Before it can start its work, the new rails are laid down on the sleeper heads by suitable transport units. After removal of the old sleepers, the RU800S excavates the ballast, cleans it, temporarily stores the reusable parts, and then reinstalls them on the track together with the new ballast. Next, the new sleepers are laid, and then the new rails are placed on the fastening points. By lifting and spreading the rails, they swap their positions on rail fastenings and sleeper heads. The rails are subjected to only minimal bending stresses as the free workspace is 45 meters long. Once the new track is in place, an 8-spindle wrench is used to tighten the rail fastenings. As there are no longer sidings on the Buxtehude Stade line, the transport wagons for the sleepers are replaced by new ones in Hamburg overnight. On the RU800S, gantry units are also deployed for the transport of 30 sleepers at a time to the laying unit in a constantly moving relay system. After 3 days of work, this job is also completed according to plan. Being on time is here routine, and subsequent work sites for the machine and its crew follow a fixed schedule. Like the PM1000 URM, the RU800S too leaves behind a track that construction trains can travel on. Of course, the track will still need to be prepared for the railway service and its precise nominal geometry established. The 094X Dynamic Tamping Express with 4-sleeper tamping and dynamic track stabilizer is used to achieve this. With its continuous method of working and the maneuverable tamping satellite, it is possible to work at considerable speed. Several tamping processes are carried out one after another. Since a further supply of ballast is required, subsequently another construction train with bulk material wagons filled with ballast follows at some distance. Ballast is a valuable resource. To prevent ballast being left lying unnecessarily, for example on the shoulders of the ballast bed, the BDS 2000 ballast management system is used on this worksite. Its shoulder plows and center plow, plus the sweeper unit in the rear machine section, remove superfluous ballast after the tamping operation and redistribute it, or temporarily store it in the bunker. The MFS wagon is running between the two machine parts of the BDS 2000 to increase capacity. An EM-SAT 120 track recording car is in operation at this worksite between the Tamping Express and the BDS. This unit for electronic pre-recording of the lateral, longitudinal and vertical geometry of the track helps to achieve the perfect end condition. The small, independently traveling satellite car first follows the Tamping Express and then remains in one position. Then the main machine will approach. Using a laser-long cord between the two vehicles, the actual geometry is determined for each section. In addition to that, the level and alignment of the track are recorded optimally in combination with fixed points on the overhead line masts. This data is then fed to the tamping machine for its next work sequence. After 27 days of intensive construction work, the track renewal and ballast bed cleaning project is completed. Safe railway operations can recommence as planned. A track upgrade and assembly line style with working technologies from Plasser and Theurer.